websites faster, and some things that are relatively simple to do that are helpful for the website. So if you looked at the meetup right up front, it's about having a page load for 1 second for a new visitor and 100 milliseconds for navigation once you're on the site. So those are pretty small numbers. You know, why I choose that? They're round numbers, but you need to understand. Everybody knows what a second is. 100 milliseconds is just as fast as you can imagine anything. There's a usability here. This is going way back to 1983. Jacob Nielsen did this usability work about people using computers. 22 years ago, I mean, it was a different, people were using websites back then, really. But we found that if stuff was happening in less than a tenth of a second, then the users would not really perceive any delay. Everything felt instantaneous to them. It was like they were acting directly on the system. This delay of 1 second or so, then
is there an outlet up
the
there?
computer is doing something, but they don't get interrupted by it. So when they start to get longer than a second or so, users lose focus. In today's world, maybe they switch to another window, maybe they check their email, do something that's going to get them off of your website. Is not what you want. And in 2015, these numbers are achievable. Kind of, we make certain assumptions, and if we try really hard. So something to think about with this 1 second and 100 milliseconds is what exactly are we measuring? There's a lot of things that we can look at. The down content loaded event, this is when the entire HTML document and everything referenced, or all the scripts and style sheets are downloaded and run. There's the window onload event. Most metrics that measure, they say page load. That's going to be the window onload, and that's going to include everything, including images, fonts. Typically, a website's going to be useful far before window onload. So, a couple metrics that are maybe a little more relevant are when the page is first rendered on the client. First visible, pixels on the screen, or the first time that most of the content is visible, or the time to when the page is interactive on the client. After your JavaScript that hooks up event handlers have run, when they can actually do what they want to do on the website. So today what we're going to be talking about in relation to this is we'll go through how exactly a modern website is loaded by a browser. So this is going to, we'll talk about what makes it slow. We'll dig into one file specifically getting downloaded, everything from the radio to DNS and all that. And we'll talk about how an HTML page full of resources like scripts and style sheets and images and fonts, how that works as well. And we'll talk about how we can optimize the process and make the entire page load sequence go a little bit faster. And before we dig into the what and how, though, let's talk about why. We're all developers. We want our sites to be faster, at an abstract level, but it's maybe not obvious to the product owners or our managers that we should be spending time doing this. But there have been a lot of studies that have found a direct correlation between speed of page load and how successful those pages are. So I'll just bring them all up here, and they're a little bit small, but the Obama campaign in 2012, they did some work to speed up their site by 60%, and their donations went up by 14% with no other changes. They didn't change the copy or the pictures or anything, they just made it faster. And as you can imagine, that was a ton of extra money when you think of a campaign site, how much money that's taking in every day. DoubleClick, the ad network, they eliminated a redirect on one of their ad platforms, and this took an average of 1.5 seconds off an ad click, and they found their click-through rates went up by 12%. So that's directly 12% more revenue they started getting from their ad clicks across their entire network. The Mozilla, this goes back a while, but on their download page, they did some work to make the download Firefox page a little bit faster. They made it load 2 seconds faster, and they found 15% more people actually downloaded the software. And then the final one, even to show a minor increase can still have an impact. At Yahoo, they did some work that they did some testing with artificial increases in load time. They found when they added 400 milliseconds of delay, they lost 5 to 9% of people. They were just leaving the page. And it's kind of strange to us because we're all computer experts basically. If we want to do something on the internet, I mean, we are pretty comfortable. We go to a page, we know it's going to eventually load. We're not concerned about anything like that. But most people are not comfortable on the internet even today. And if a page is delayed, they get frustrated, they think maybe they're not in the right spot, or life happens and it's easy for other stuff to get in the way and they don't continue with what they wanted to do, what you as the website developer wanted to do. So there can be a real financial impact across any performance improvements you can make. So the bottom line here is the faster sites are just more successful all around. All right, well, I've lost my clicker here. So when we talk about speed, there are kind of two factors that we need to keep in mind. There's latency and there's bandwidth. So latency is going to be the inherent delay for any request. It's based on pretty much geography and the speed of light. If there's a server in San Francisco, it's hosting a file, and it doesn't matter how big that file is, the fastest we can possibly get that to a computer in Minnesota based on the speed of light, physics, is about 20 milliseconds. And typical latencies are going to be really close to that, maybe 30 milliseconds. 10 milliseconds of overhead or so is about the norm. Some related terms to that, RTT is a round trip time. That's kind of one latency unit. So, if you say this takes 5 RTTs to download 5 files, that's like 5 times the latency unit. Time to first byte is going to be, time from the request to when the server actually sends you something. So if there's delay on the server, that's not latency per se, but it's wrapped up in the time to first byte. Bandwidth is the download speed, like how many bytes per second are going over the wire. And this is limited by infrastructure. We can build faster, better pipes, and bandwidth will always go up. But it's also limited by concurrent downloads. Your internet connection is your total internet connection for your house or your business or your computer. Another factor with bandwidth is TCP, slow start. When you first start downloading a file, it's not at the fully maximum speed. It sort of ramps up over the course of about a second or so. And this is so that if you download 10, if 10 downloads start to happen at once, they don't all try and consume the entire pipe and stomp all over each other. Anyway, it's part of the TCP protocol that's baked into the internet. So if we look at the total download time for a resource, it's going to be the latency, which is sort of fixed and set in stone regardless of how big the resource is, and then the size of the resource divided by our effective bandwidth. So some typical values for this, if we're cable or DSL internet for home or business, you'll maybe have 20 megabits bandwidth, 40 millisecond latency. A 4G LTE connection is about twice as slow in both respects. 3G, I have that grayed out because if we're going to talk about 1 second and 100 milliseconds, no way that's going to work on 3G. But it's useful to know. It's significantly slower than 4G. Maybe 1 megabit and huge latency. So one thing to notice with these numbers is the bandwidth, the latency delay will be about equal to the bandwidth delay for 100 kilobytes. That's kind of big. So jQuery, for instance, people like to rag on jQuery these days because it's too big of a file. That's 30-ish kilobytes. So 100 kilobytes, what that tells us is that the latency is going to be a bigger factor than the bandwidth for most of the things that we put on our page. So when a request is made, there are a bunch of things that go on at lower levels, and they're all going to impact the time that it takes to download something. So if we're on a mobile device, the radio's got to wake up and connect to the tower. If it's a new site, we're going to do a DNS lookup to figure out what the IP address is of this server. It's going to have to establish a new TCP connection. And if it's a secure site, it's going to have to download, it's going to have to negotiate TLS to set up security. And then, so that's sort of the first half, and we don't have too much control over that. The second half is going to be the request upload from the client, which for a web page is just going to be a GET. Any processing we do on the server, the download to the client, and then finally any processing that has to be done on the client to display that resource. So these first four that we're sort of stuck with, it's useful to know how much they're going to impact us. So the radio wake up in particular, if we're on a mobile site, and this is with 4G LTE, which is sort of the top of the line today, you can assume anything older technology is just going to be in general worse. But if we're on 4G and our phone's been idle for 10 seconds, the radio shuts off. And it's going to take a quarter of a second to spin the radio back up, connect to the tower, and do anything at all. If it's been even as long as 100 milliseconds, it sort of does a half sleep where it will disconnect from the tower. And so then there's some extra overhead as soon as you do anything again to reconnect to the tower. And so 100 milliseconds is, I mean, there might be 100 millisecond delays in the course of loading a single page. So that second sort of inactive state can interrupt us even as we download a single page. The DNS lookup, ideally that's going to be cached, but if it's a new site for that user, it's not going to be cached on their device. And ideally it's cached on ISP, but even then, maybe not. A lot of people use content delivery networks today. Those will typically have a low DNS TTL, like 60 seconds or so. And what that means is that it's saying to the ISP, do not cache this DNS entry for more than 60 seconds. And so, you're sharing a DNS cache through your ISP with many, many users, but if none of those users have hit the same website in the last minute or so, then your users will be paying the cost of a DNS lookup for your site. And another thing that gets into this is, as we're using kind of secondary domains and content delivery networks again, some of the domains are less used. So TCP connection, that's sort of the level below HTTP in the network stack. That's just the ability to send binary data back and forth so that we can send web pages on top of that. That's going to be one RTT, one latency unit. TCP keep alive is a way that the server and the client can maintain a connection after a download has finished so that it doesn't have to be reopened. You'll want to make sure that for any web, you want to have that enabled on the server. And that lasts for about a minute. So if your user is navigating around your site, and as long as they're not inactive for over a minute, they're going to maintain the same TCP connection. And then the final thing we don't have much control over is the TLS or SSL negotiation. So that's going to be 2 RTTs, 2 round trips. Additionally, the client has to do some CPU processing to verify the cryptography, and it also might have to go out and do server checks to see if your certificate has been revoked. If you configure your server correctly, you can get it so it is sending a little message with your certificate that says this hasn't been revoked. But it's not something that is configured out of the box usually. TLS resume is a way, it's another server configuration where part of this security negotiation can be skipped the second time for a user. But we're always going to hit some delay with the extra HTTPS. So like I said, those others were out of our control. The rest of these, the upload, the server time, the download, the client time, these are what we can really optimize. So this is, we decide what the requests coming into our server are going to look like, and what we do with them, and what we send back, and what the browser's going to do with them. So there's going to be at least one RTP in there for data to go from the browser to our server and back. And the browser is going to take at least 100 milliseconds to render something based on what we send it. But everything else is under our control. So to sort of sum all this up, here's a table, sort of in relation to the numbers we talked about at the beginning. So when we've got radio wake up, DNS, TCP, TLS, and then the portion of the rest that we can't control. For mobile, on our initial navigation, we're already at 850 milliseconds. That doesn't give us much time. On the desktop, we're a little bit better. Same for our secondary navigations. We're going to have, we're already over our budget. So if we really want seemingly instantaneous navigation, we're going to have to do some tricks. And this is for one HTML document. I mean, our sites are not just one HTML document. They're HTML that reference scripts and style sheets and images. there's more to think about. So let's talk about it. This is a little bit small, but this is some HTML source with some style sheets in the head, some JavaScript in the head, some more JavaScript at the end of the body. You know, a pretty typical web page that we might set up. So to kind of walk through the process of loading the page, you're going to wait for the HTML, and then the browser is going to get the HTML. Then they'll get that, it'll immediately request everything, you know, from the head and the body. It's going to scan the entire document at once. Once the JavaScript from the head and everything from the head is downloaded, then it'll be able to render the page. It might not always render the page. The browsers are a little bit inconsistent on this, but if it's downloaded all the scripts, it'll just go ahead and run the rest of them before it renders. But if you have a big delay, it will render a partial page like this. Then once we get the rest of the JavaScript, it'll run that, fire down content loaded, it'll run any JavaScript that's not down content loaded, and then finally we're done, our page is ready. So there's a lot that's going on here. And sort of the key takeaway is that, you know, the faster we can get the JavaScript and the CSS to the user and the HTML, you know, everything kind of waits for the step before it. So it all has a linear relation to, you know, as we speed things up, the entire experience gets faster. So one way to visualize this process is with something called a waterfall diagram. So it's a visualization of HTTP requests on the page. This image was generated by Fiddler. Does anybody use Fiddler? Yeah, hopefully a lot of people do. Fiddler's awesome. It shows you all the HTTP traffic happening on your machine. And so this is the timeline view. So if you load a page, select a bunch of files, go to the timeline view, it will show you, you know, how long each took. You can see the 1 second way up there, this line here. And so this is for jsfiddle.net. You can see it loads the HTML, and then the JavaScript, and then CSS files, and then more JavaScript here at the end. And so based on what you know is in your page and what is actually being downloaded, you can sort of figure out, well, what, you know, at what point in here is the site actually ready? So Fiddler shows you only the HTTP traffic. There's more to it than that. The HTTP archive is a file format that will show you, it contains all the details. DNS lookups, TCP connections, SSL certificate stuff. You can get it in browser debug tools or there are plugins for it. So like the Chrome Network tab shows this, or I think you need a plugin for Firefox. Webpagetest.org, you can enter in your website, and it runs on a cloud server, basically a simulated load of your page, and will generate this for you. And that's nice because it's sort of an objective measurement. You know, if you do it on your own machine, it's subject to your computer, your internet connection, all that. Tools@pingdom.com is another one that's pretty good, that does the same thing. And a lot of these will export to the HAR format, which means that you can move files in between these, and there are different tools to deal with HAR files. A couple things I want to point out about the Fiddler diagram. So if you can see these CSS files, they all have the black bar right on the end. Whereas like this JavaScript file has black bar kind of in the middle. The black bar represents the time to first byte. So what you can tell from this is that these purple CSS files are probably pretty tiny, because once we get the first byte, they're done. Whereas this JavaScript file, we get the first byte and there's an extended download. So you can see that for, you know, all those CSS files, the latency is completely the dominating factor in how long it takes. So PerfViewer.js, this is something I did myself a few days ago. It shows a waterfall diagram in the page. It's based on the HTML5 resource navigation timing. So, you know, if you want, you can go to my website, add the script to your page. It will show you at the top, you know, this page loaded in X number of milliseconds. You click details, you get a waterfall diagram. Or you can make it a bookmarklet and just have a button on your browser. You can click for any page that you go to at any time. So yeah, For cross-domain requests, it doesn't show latency info. So sort of the light colored portion of the bars is before we've received anything, and the dark portion is during the download. So just like the other ones, you can see like these green ones, there's a lot of latency, there's a lot of time up until the download starts. Some of these others, not so much. For cross-origin requests, the resource timing API doesn't let you see the latency part of it. It just lets you see the entire thing for security reasons, so it's not foolproof in that sense. But anyway, if you check this out, send me a note, tell me what you think, if it's useful. Okay, so to recap where we're at here, whoops. When we talked about how websites get loaded, what makes them slow. For all the way, we kind of dissected a single download of a file and all the steps that go into it. And we went through, page flow resources and how that gets loaded. So now we'll talk about some ways that we can optimize the process. Number one thing is make your server fast. The HTML getting sent to the client is going to hold everything else up. Until you get that HTML, the client is just stuck there doing nothing. So I'd encourage you to target 100 milliseconds as your server processing time for any page. That's pretty aggressive, and it means that you might have some things that don't fit. And what you can do is you can move expensive database calls and that sort of thing and load them with an AJAX call. So suppose you've got a page and it's got a bunch of content on it, right? And maybe one piece of info on the side takes a long time to look up. You can render the rest of the HTML, send that down to the client, and have them initiate an AJAX request to fetch that expensive info. Another thing you can do to improve things, especially for your first-time visitors, is to flush the head, flush the HTTP response after the head. This will get the browsers downloading scripts and style sheets right away. So if you have expensive processing, that's probably going to be in the body of your page, not the head. You send the head right away, then the browser can download the scripts and style sheets while it's waiting for your server to finish. I should have put the link in here, but there's a good project. It's called Courtesy Flush. It's for ASP.NET MVC, and you can basically configure it for your pages, and you can, in your Razor view, add I forgot what to call it specifically, but it makes it very easy to flush the head of the response to the browser. Another thing that works in some cases is you can make your HTML server cacheable. So if you have personalized information on the page, then you can't really cache the pages on the server because they're going to be different for everyone. But if you can take all the personalized information out of the HTML, then you're in a good situation because you can cache things on the server. So things will be really fast for most of your requests. Okay, we'll have an example for this one. Eliminate first vendor dependencies. So we saw when we walked through all the resources that are downloaded by a page, all the stuff that has to happen before anything is shown on the screen. Well, if those are in external files, then they can take a long time. That can take a long time to happen. So if you inline the bare minimum of the CSS and the JavaScript needed to display the page, then stuff will load really fast. And this is progressive enhancement helps with this as well. If you make your script tags async, that means they're not going to block the render of your web page. So this, you put the async and defer attributes in your script tags. They'll get executed after your document is loaded, and they won't slow anything down. Of course, you got to make sure that they work in that scenario. Depending on what you're doing, it might not be a fit. And specifically, you can't do anything with document.reg if you're going to use async. So a great example of this is theguardian.com. So this is what theguardian.com looks like when only the HTML has been loaded. No style sheet, no external style sheets, no external images, nothing like that. You can see it all looks right. There are even images. There's an image of a little home there. It's pretty pixelated in here, but it's astonishingly fast if you go there. I'm just going to pull it up as an example here because it's pretty nice to see. can't see the end. Okay, I'm going to hit enter now. And the whole thing loads at once, it's very fast. It's so fast mainly because they're inlining everything. So that's one technique you might think about using. Okay, gzip compression for static content. This is pretty simple. Hopefully we're all doing it already. It's going to reduce your text file size by about 70%, depending on what's in the text. Don't try and use it for images or any kind of multimedia or anything like that. It's not going to help, it's just going to slow everybody down. But use it. Please use it. If you have secure dynamic content on the page, you want to be careful with this. There's this thing called a breach attack, where somebody sets up command in the middle proxy, and if you are gzipping secure content, they can manipulate requests to basically try and figure out some secret info on your page. Gzip, if you have duplicate content on your page, will be more effective. So if they can manipulate your page into echoing some kind of the input, then the man in the middle can tweak that input to try and match a secret on your page and notice when the compression shrinks the response further. So even though you're using HTTPS and they can't read the actual content, they can still see how long it is. So if a lot of people use gzip with dynamic content, and a month ago I was telling people to use gzip all the time for everything. I'm a little bit scared of it now. I don't know how practical the breach attack actually is, but it's maybe not worth it.
I think if you add a few characters of heading to your page, it defeats the attack.
Yeah, so if you can append like a random length to your page, and it will help mitigate it. It sort of makes it harder for attackers to figure it out. But if your length is fixed, then everything still works the same way it was. If the length you add is random, then they can make enough requests and still sort of figure it out.
But it's exponentially harder for me.
Yes, it's exponentially harder for sure. So, depending on what you're doing, it sounds like you're familiar with this. If you know what you're doing as far as the breach attack, then go nuts. But I just want to make sure everybody is aware that it's there. Okay, caching strategy. So, with HTTP, we have caching headers. There are a couple different headers. There's cache control, which is sort of a Swiss Army knife of everything that we can say about a resource and whether it can be cached. So for instance, public max age equals 3600, saying this is the same for everybody. Everybody can cache this for 3600 seconds, which I think is an hour. Private would be another option that says only the browser level can cache this. Reverse proxies and CDNs and those sort of things can't cache this because it's personalized. No cache, no store is what you might use for something that's secure info that you wouldn't even want to be cached on a browser. So maybe banking info or something like that. Alternatively, or in addition, they're etag and last modified. These are headers that are basically about the file itself. So etag is typically a file hash, a bunch of text gibberish, and last modified is going to be the date time of when that file was last modified. So sort of the best thing to do with your cache headers is to, whenever you reference a static file, include a version in the URL like this. So here we've got a CSS file, and the version is going to be a big hash, which essentially would be the same as the etag if we're using etag. And then when you do that, you can say cache this thing for everybody forever, because if the file changes, you're not going to be referencing it with a new hash. If you use the etag and last modified, that's certainly better than nothing, but the browser has to make what's called conditional requests, where it says, all right, has this file changed from this etag? Or has this file changed since this last modified date? And the server can say no, it will return a 302 or 304 node change. And so there's no download happening, but you still incur a latency hit on that. So yeah, the conditional headers come with the e-tag, or conditional requests happen when you use the e-tag unless modified. IIS out of the box for all your static files will do e-tag unless modified. So if you're putting together a Razor page or any ASP.NET page and you're referencing scripts, those static files are going to come out of IIS with an e-tag unless modified. And then when if your user hits F5 refresh, for instance, the browser will send conditional requests for all of them. Or if they come back to your site 2 days later, the browser might request all of them. Basically, if you don't specify a max age in your cache control, the browser uses heuristics to figure out when it needs to go check again. And different browsers do different things, but you want to avoid the 304 not modified if you can. So sort of the best way to do this in Razor is to use bundle config for everything. Bundle config throws that version tag in if you're referencing it with the render scripts. And so this can get to be a pain to put everything in bundles, even when it's not really a bundle. I'm currently working on a library to help solve this and make version URLs easy to deal with. If you're interested in helping me out with that or trying it early on, I'd love to hear from you. So you can check out my GitHub for that if you want to. Another thing to keep in mind is that just because you're caching things well does not mean your web page is fast. Caching, it helps returning visitors and it helps navigation within your site. But it doesn't help new visitors, and it doesn't help if you update your cached files every week. So for instance, this screenshot, it's somebody's using version URLs based on sort of the last modified date. And you can see 2015-0320. I took this screenshot on like March 24th. And then I happened to go back to this page again a week later to see what it was, and all these files re-downloaded again. Now they were 2015-0326. And so, if the caching is only going to help if your user has a file in their cache. Yahoo did a study, this was several years ago, and they found that their cache hit rates were a lot lower than they expected for users. So this was back in the time when Yahoo.com was a top 3 internet property. It was huge. Everybody was going there all the time. And they found that 40 to 60% of their users' navigations to Yahoo.com would get a cache miss on a commonly used file. And for all page views in aggregate, they'd have 20% of page views get a cache miss for a static file. And this is because either the file had been updated, or the users hadn't been to that site before, or the users had cleared their cache, or mobile browsers have a really tiny cache. If somebody's visiting your page on a mobile site, it's pretty unlikely anything is going to be cached. So keep that in mind. It's good to set up your caching correctly, but it's not good enough. So another thing you can do to help is optimize your file delivery. So Nginx, anybody using Nginx here? Anybody heard of it? All right, so a lot of people have heard of it, not as many people using it. It's a pretty simple server, and what it's really good at is serving files and doing reverse proxy serving. It's way faster at serving files just at a low level than Apache and IIS. You wouldn't think that serving files is really going to be taking too much capacity off of your box, but if you think about how most web pages work, static file requests are going to be a large chunk of the actual requests incoming into the server, downloading scripts and style sheets and images and stuff for the first time. So putting an Nginx reverse proxy in front of your IIS or using it to serve the files directly will speed up the file delivery. Another option is a content delivery network, a CDN. So this is basically a file server that's geographically distributed around the world. So instead of serving all the images from the server in your data center, you're serving it from serving it from a data center that's close to your user. And they're really, really good at serving files because that's essentially all that they do. These are large companies who, their specialty is serving files statically. So they've spent a lot of time making it work fast. One thing that I didn't realize, a year ago was that CDNs can work on your same domain. Oftentimes, when you're using a CDN, you end up using a different domain for your CDN. How many people have done that? Seen that where it'd be like static.something.com has all the images, and you can do that, but you don't have to. Most CDNs will let you serve, use your CDN for your main domain, and if it's a dynamic request that can't be served by one of the static files, it will just get it from your application server. So the downsides to using a CDN are you get a low DNS time, expire time, like I was talking about before. The way that, one of the features of CDNs is that if data center goes out, users in that area will now be getting files from a different data center. And they do that with DNS, where if a data center goes out, they change their DNS records to point to a different one in that area. That means they have to keep a low timeout for their DNS servers, and that means there'll be more DNS lookups if your site's being served through a CDN. Yeah, you're right.
Isn't there still an advantage to having separate domains though? Having your browser hit separate?
Yes, we'll get to that.
Okay.
Yeah, so you're right saying there are advantages to using a separate domain for your static files. Yes. Another issue with CDNs is purging a file. So suppose you have a static file that's you've set up as cacheable and now you want to change it. It can be, it's more complex with the CDN to sort of erase all traces of that file. If you're serving everything from your local, from a single server, you can just delete the file and restart the server or whatever, and it'll be fine. With a CDN, there will be, most have an API to purge content, purge a specific resource from the CDN. Okay, use HTTP 2 or Speedy. So Speedy is, HTTP 2 is out now. It's been ratified. It's supported in Firefox, Chrome, Android Chrome. In the new versions of IE on Windows 8, it's supported there. So it's over half of clients, over half of browser clients supported today. Server support is still a little bit shaky. Speedy was sort of an experimental protocol. You can think of it like a beta for HTTP 2. It's been around for a couple of years now, and basically it exists so that companies could see what works and what doesn't as far as these new protocols. So the biggest feature of HTTP 2 is what's called connection multiplexing. What this means is that a single TCP connection can serve multiple files. So, if you have a page and it includes 6 JavaScript files and 6 style sheets, that used to involve opening up many different TCP connections to download the files separately. Well, with HTTP 2 or Speedy, they can all be downloaded at the same time through the same connection. And there are prioritization schemes that go along with that. And, some of it gets pretty complicated, but the bottom line is you don't have to worry about separate TCP connections anymore. So like I said, some of the caveats are limited service support. The only CDN that supports it as of now, according to their marketing anyway, is Akamai. I'm sure the other CDNs will be coming out very soon. Nginx, for instance, as a server product is going to be supporting it by the end of the year, they've said. I'm not sure about any plans for HTTP 2 on IIS. I'm sure that it's in the works, but I haven't seen any announcements or anything like that. Another sort of caveat with it is it requires HTTPS. If you have a plain, non-secure site, the browsers will not use HTTP 2 for it. It's technically supported by the protocol, but the browsers don't do it. And so, like I said, in theory, there's a performance benefit here. I've heard rumors of sites turning it on and things just magically get 10 to 30% faster. And that's, what I haven't seen though are like a concrete case study like, hey, we had this site and here was how long our page load was before, and then we switched to HTTP 2, and now it's like this. So I'm a little bit at a loss for why that is, because it seems like it should be helping people, and I think it'll be just a while before any concrete info is published. Anybody here using HTTP2? Because I'd love to hear some actual real-world experiences with companies turning it on. No? Okay. That's pretty common. Not many people are actually running it on their server yet. All right, so bundling resources. This is another sort of hack to work around TCP connections. So what you can do is you can have one file that will basically include multiple resources in it. So it's pretty common to do this with your JavaScript or your CSS, or with your images as image sprites as another form of bundling. So it'll reduce the number of requests. So here we've got, this is a grunt script, and it's really simple. There's a grunt concat plugin, and you say, okay, these are my 3 scripts that I want in the bundle, and here's what I want my bundle to be called, and you run grunt, and it will just concatenate all these files into there. And now you reference this bundle in your page, and you're downloading, the user's downloading 1 JavaScript file instead of 3. You can also use bundle config in ASP.NET. That does the same thing, and so it reduces the number of requests, so it reduces the latency problem. It introduces a problem of cacheability. So script 1, script 2, script 3 are now all in one file. If we update any of these 3 files, we have to expire the bundle from the cache. So it's overall going to be a win if you're not changing your bundles all the time. But you may want to segment your bundles. So rather than, if you have 100 JavaScript files, you might not want to put them in one bundle. Maybe break them up into 2 or 3 of ones that change all the time, and ones that change rarely, and ones that are maybe third-party scripts that basically never change. It'll improve your cacheability on those things. So with HTTP2, doing bundling is useless, and because of the cache problems, it's actually harmful. So you don't want to be doing bundling with HTTP2. So this is sort of a technique that it's still very helpful today, but it's on the way out. Optimizing images. So image files are 2/3 of the average web page total bytes downloaded today. So like the average website served up is 2 megabytes in total resources, and 2/3 of that, 1.3 megabytes, is images. JPEGs, things, GIFs. So the first thing is, when dealing with images, is making sure you're using the right format. So for JPEG, that's when you have lots of colors and you have fuzzy edges. A PNG is for if you have line art and relatively few colors. So if you're doing like a screenshot or something like that, you want to use ping. If it's a portrait or a picture of nature, you want to use a JPEG. If you try and use a JPEG, the fuzziness doesn't show up on the projector here, but if you saw this picture on my computer, it's a JPEG and it looks awful. There are pixel blobs all over the place. GIF, GIF, whatever you want to call it, has the same sort of goal as ping. So the main reason you want to use it if you have anything animated. Other than that, ping will usually be better. And BMP files never use that. Occasionally I'll see a BMP file on the internet and I cringe. But BMP is completely uncompressed. It's basically 4 bytes for every pixel. These file formats do a lot of work to optimize how they're storing this content. And bitmaps do absolutely no work to optimize how they're storing the content. So don't use bitmaps. Another thing that's very important is to choose the appropriate size. So, and this is more of an issue as we're doing responsive sites today. So I apologize again, it's a bit small, but in HTML5 there's a picture element. So it's a picture tag, and within it you can specify different images to get loaded at different CSS selectors essentially. So here we've got a picture, we've got a source for min-width of 64 ems, and then the source is high res. Another source with media min-width 37 ems, and the source is medium res. Or if it doesn't meet either of those widths, then the source is going to be low res JPEG. And then to deal with browsers that don't support this picture element, there's a standard image tag with a fallback JPEG. And this is going to load on the browsers that don't support this. This picture is in Chrome, it's in Safari, I believe, and it just landed in Firefox. So it's in the latest version of Firefox, but not everybody's using that. And then your alt text for a picture just goes in a paragraph. So by doing this, you can avoid sending, the 1200 pixel wide image for your website header that you love for a desktop site. You don't want to send that down to, an iPhone or some small little Android phone. The other thing to do with images is to optimize them. So even once they're in the JPEG or PNG file format, a lot of times they are not using those formats efficiently. So there are tools that will strip unnecessary metadata and sort of re-encode the files so that they use less space. Photoshop has a save to web. It's better than nothing, but it's not very good. I'd recommend using a dedicated tool for this. So, you can save up to 75% on the size of the JPEG or PNG. So on the command line, there's Image Optim, which I believe is just for JPEGs. There's Ping Crunch for PNGs. There are several different web-based tools. My favorite is Kraken.io. It's, you go there, you click a button and you upload an image and it optimizes it for you and lets you download it. There are some slicker ways that it can integrate into your workflow. There are also image services that act like a CDN that you point your DNS at them to serve your images and they'll serve an optimized version of your image. So optimizing images is not very difficult. It's something you should be making sure that you do if you have any image weight on your site at all, really. Yeah, so here's an example. These polar bear images, one is 50K and one is 18K. I'm not even sure which is which. On the projector, of course, they look completely the same, but even on my 1080p laptop screen, no way I could tell the difference. Okay, avoid multiple domains. So this is kind of going to what Uriah said. So sort of long-standing advice has been to use this domain sharding. So the idea is, your site is served from www.yoursite.com, and you serve images from image.yoursite.com, and maybe image1, image2, image3.yoursite.com. Multiple domains so that you can get more files downloading in parallel. And so this has been a good technique in the past because you get more parallel downloads. And the other advantage to using a separate domain is you avoid cookie uploads. So, if on your site you've got a session cookie, right? And maybe you've got more stuff in your session cookie besides a token. Some sites have hundreds of kilobytes of cookies. If you have all your images on your main domain, your browser's going to have to upload those cookies for every image request. When the images are just files, they don't actually need your cookies. So if those files are on a separate static domain, you can get some better performance that way. There are a lot of cons that go with this, though. So 6 per host. The browsers will allow 6 simultaneous connections to a single host. And so if you've got your images spread across 4 domains, well, now you can be downloading 24 images at a time, which seems like it's great. But you run into what's called TCP congestion, where you're downloading so much stuff at the same time through the same narrow pipe that they conflict with each other, and you end up with a slow overall experience. You have extra DNS lookups for these other domains, potentially. You have extra TLS negotiations. If you have a secure site, all of the images on your site have to be referenced with HTTPS. That means all those domains are going to need a TLS connection that's going to have to be negotiated separately for each of those 24 connections. And then it's extra complexity in the code as well. You've got to maintain the fact that your static files are on a different domain. And we've developed ways to deal with this. It's not rocket science, but it's one more thing we have to deal with. And with HTTP2 and SPI, doing this is completely obsolete. Cookies are compressed with HTTP2. This is another feature. And they're compressed in such a way that if you do multiple requests with the same header values, the same cookie values, it's really going to just send a pointer to say, hey, use that same cookie I sent you on the last request and the last 20 before that. So through an HTTP2 or speedy connection, cookie upload isn't really a problem. For HTTP1, it's probably still good to have 1 or 2 additional domains. But common practice has been to use 4 or 6 or more than that. I'm just going to write up what I got referenced here at the bottom. It was about Etsy.com. And Etsy is a company, you know what Etsy is? It's like, yeah, okay. They're really obsessed with performance. They do a lot of work to make sure Etsy loads fast. Like they've got a dedicated team of like 6 engineers who just do performance work for Etsy.com. And they found, and they did a write-up about this, was that they were using 4 different image domains to load their images, and they were hitting this TCP congestion problem really hard. And so they showed that these downloads were all conflicting with each other and slowing down the page load by a lot for their users. So use 1 or 2 extra domains maybe, but this is another technique that's kind of going away as time goes on. Minimize web fonts. So, web fonts can be a big performance problem. They're totally sort of incompatible with eliminate first vendor dependencies. They're a big pain because each different browser has to load a different web font. So we all know you need a library to load your web fonts. They're pretty big. They're 20 to 100 kilobytes for a single web font file. And the browsers also have different behavior while those are loading. So Firefox has a web font downloads. It'll just show the text in plain old sans serif and then switch it when the font loads. Chrome will show no text and then show the font once it downloads. IE, I guess I'm not sure what IE does. There are libraries that can make you emulate one behavior or the other if you really care that much. Basically, your designers might want to use web fonts. They're great, but they're kind of annoying for performance. So you want to streamline them. Maybe you don't need this bold specific font. Maybe you can just use CSS font weight bold on the standard font, so you don't have to download 2 separate font files. Another thing you can do is font files have typically lots